Okay, so the good news is that solving inequalities, we follow the same game plan. However, there is a slight nuance. There's a time we have to be very careful, and when we are solving a linear inequality, if we find ourselves multiplying or dividing by a negative, we have to be careful. There's some things we have to do about it. So let's talk about that issue, and then we'll do another round of solving, and we can take care of it. So to understand why this happens, let's take a look at an inequality that we're pretty comfortable with, right? I think you guys would all agree that 2 is to the left of 3, or negative 2 is less than 3. I can even visualize this on a number line. So here's 0, here's 1, here's 2, here's 3. So there's 3 on my number line, and there's negative 1, negative 2, negative 3, negative 4, and there's negative 2 on my number line. So clearly negative 2, right, is to the left of 3. So that is a true inequality, right? But look what happens if we multiply. In a case, it would also be the same thing if I divided by negative 1. All right, so if I multiply or divide by negative 1, if I take each side and I multiply both sides by negative 1, this side now becomes 2, this side becomes negative 3. All right, and then the inequality, right, if we weren't careful, if we left the inequality like it was, I now have a statement that's not true. Because you can see, right, because of the negative, we have created, let me try to mimic the one right up top there. We have introduced the concept of oppositeness, right? So what was negative 2, by multiplying it by negative 1, has become a positive 2. And what used to be 3, by multiplying it by negative 1, has become negative 3. So there's been a literal flip-flop, if you would, right? So we used to be true this way, but now we're true the other way, right? And so that's no longer true. What we need to do is flip-flop the sign. So you can literally see that the relationship is this way, but by introducing the concept of opposite, whether it's multiplication or division, the relationship between these two numbers literally flip-flop, all right, through the number line. And so to match that, right, I have to flip-flop the inequality. And notice I now have a true statement. 2 is to the right of negative 3, or 2 is greater than negative 3. So that's basically what you do. So so when you multiply or divide by a negative, right, you need to accompany that with a flip in your inequality. Okay, I'll just use the word flip. So you either change it from a less than to a greater than, or vice versa. All right, and that helps you keep the correct solutions all in place. All right, so let's see that in action. So to solve this first one, right, to get this x by itself, I would have to divide both sides by a negative 3. And since I'm dividing by a negative, I need to accompany that with a flip-flop, right, in my inequality. So it used to be a less than is now a greater than. The negative 3's cancel out, leaving us with x. And we get that at 12 divided by 3 is a negative 4. And so the solution in this case would be x is greater than negative 4. All right, so there's that demonstration. So everything else is the same. I'm following the same game plan, but I found myself dividing by a negative, accompany that with a flip-flop inequality, so the math makes sense. In the next one, we got to get x by itself. We have to deal with the fact that it's being multiplied by negative 2/5. So perhaps I just take that side and I multiply it by the reciprocal. Of course, whatever I do to one side, right, I have to do to the other. Because I'm multiplying both sides by a negative, right, I have to take what was my greater than symbol and convert it or flip it to a less than symbol. So every time you multiply or divide by a negative, when you find yourself doing that in your work, you must accompany that with a flip-flop in your inequality. Over here, a negative times a negative is a positive. 10 over 10 is 1, so we're left with x. And then on this side, we have, I guess it's negative 40 over 2, and that reduces to negative 20. So our example there, so the inequality, the values that make this statement true are values that are less than negative 20. All right, and again, let me pause for a moment. We'll take a deeper look at what these solution sets mean in another video. Right now, I'm just concentrating on solving and taking care of business when you multiply or divide by a negative. Last but not least, in number 3, before I do anything, I have to do some simplification. So I would distribute on both sides. We're distributing a minus, so all the signs change behind us. Combining like terms, we end up with 2x plus 2, and that's, I think, 4x minus 2. All right, so I think I combined terms right, yeah. And then, so collecting like terms, perhaps I subtract 4x from both sides, right? And while I do that, I can subtract 2 from both sides. And notice the inequality is not changing yet, right? Because all I've been doing is adding and subtracting. I have not multiplied or divide by a negative in any of my work yet. So doing this, the 2's cancel out. 2x take away 4x is a negative 2x. 4x's cancel out. A negative 2 divided by a negative, a negative 2 minus 2 is negative 4. And so now we see to get x by itself, I would have to take both sides and divide it by a negative 2. So because now that I'm dividing by a negative, I need to accompany that with a flip-flop. Alright, so over here we get x, and negative divided by negative is a positive, 4 divided by 2 is 2. And so there would be your solution set for that. So good news again is that solving inequalities use the same game plan. You just have to be extremely careful when you multiply or divide by a negative. You've introduced the idea of an opposite, and so the relationship between numbers now changes. It literally flip-flops position on our number line. So you change the direction of your inequality whenever you divide by or multiply by a negative. Okay? So now let's go focus on what these inequalities mean. All right? So that'll be our next video in our wrap-up of section 2.6.